Filling of atomic orbitals. Now, when I was leaving yesterday, I asked you to do something. You said no. I asked you to do something. I asked you to read ahead. Were you able to search for it? Did you? Toby, did you? Did you? There was something I asked you to read in respect to that. I talked about police exclusion, right? And Horn's principle and half bow. Did I? I said you should go and read about it. I did not teach you. Joy is still saying yes. She's my witness. But did you read it? Okay, can you tell us anything about any of them? Are you clapping? You don't need to stand, you can just explain.
I have the same number.
No two electron can
have identical values.
No two electron can have identical values.
Like they can't have the same value in the principal, azimuthal, magnetic, and spin.
Okay, even go as far as azimuthal, the spin, and the. That's very nice. That's very nice. That's very nice. Hello. Hello. Please, when you are asked to read anything, try as much as you can. Even if you did not read it, open it and see it. So that when they are talking about it, it will not be too hard for you. Is that okay? It's for your own good. Are we together? So are you having any question from yesterday's class? Can we move forward? Okay. Now let's start from half-been principle. You can write the name, right? The name half bow. The name half bow is a German scientist. Is a German scientist. The German scientist's name that worked on the principle is a German scientist's name. Yes, that worked on the principle have you written that? Of electronic configuration. Principle of electronic configuration. Are we together? Then right. Half been this, which means half been, which means build up. Build up, build up, build up, build up. Now, right. Alpha principle dictates that electron will occupy orbitals. It dictates that electrons will occupy orbitals with lower energy. Alpha principle dictates that electron will occupy orbitals with lower energy before occupying the higher energy level. And it says the energy of an orbital is calculated. The energy of an orbital is calculated by the sum of principal quantum we have been doing quantum in physics, we are doing quantum in chemistry. Principal quantum by the sum of principal quantum number and azimuthal quantum number. Now we are having chromium. What's the atomic number for chromium? Atomic number for chromium. Atomic number. Chromium. I think it's still between the range of 20 and 30, right? So if you said what? 30. 24. 24, right? 24, right? Okay. If we want to use a short notation to represent this, right? We have what? AR. We're going to have what? 6. Now, this 6, we're going to be having 3D 5 4S1. Now we're going to have the reason why this is that way. You can copy what you're having on the board. There's an exception to alpha principle. Such as chromium. There's an exception to alpha principle. Where are you? There's an exception to alpha principle. Such as chromium and copper. Are you watching? We're supposed to be having argon 3D4 4S2. This is what we're supposed to be having according to alpha principle, right? Right? But this is what we are having. And the reason is because argon does not obey Arbor principle. Chromium and copper does not obey Arbor principle, because when they are in a reaction, I'm explaining. When they're in a reaction, there's an increased stability by half, 1/2. You understand? So that's the reason why it will not obey Arbor principle.
Because what you
Okay, right. Are you writing now? Because in a chemical reaction, yes. Right. I'm explaining why copper and chromium will not obey Arbor principle. Are we together? Because in a chemical reaction, there's increased stability by half. There's increased stability by 1/2. There's increased stability. Reaction. Again, it has filled subshell. It has filled subshell. Filled subshell. Filled subshell and relatively low energy gap.
And what?
And relatively low energy gap between 3D and 4s. Between 3D and 4s. Gap. Low energy gap between 3D and 4s. Sorry. When you're taking your shea exotic and your Hollandia yogurt, do not give me now, my eye is turning. You are saying I'm writing 4-4. Write 1-4, don't write 2-4. You wrote 2-4. That second one is for you. Now let's look at how we can get the electronic configuration using SPDF. I know you are good at it. Do they allow rough paper in JAM?
Yes.
You people that have written JAM before are talking, you should not talk. You understand? Hola? The rough paper.
You share the pamphlet and instruction. Then what they did. The shared instruction, then how to write the jam, then the space down for your rough work. So all centers.
It's not all centers.
Okay? Carry white plain sheet from the house. They are not allowed to enter. White plain sheet. Would they allow pencil? They will allow pencil and eraser.
Your pencil.
Hello? Carry your pencil and eraser. Don't use pen. They don't allow eraser. Yes, you wipe. If I'm having a little paper like this, I can use this for rough work. You understand? I can use it for rough work. My 100 level, I was not given at the time we were writing tests, we were not giving my ID card. So we're using our admission letter to enter test hall. And it's E. And you are showing physics E. So I use my admission letter. They did not give us rough paper. I use the admission letter. With the pens I'm having, I'm writing and I'm erasing. If they will allow eraser, it's the best. Don't use biro to write. As you are writing, you are erasing. You have enough space. You understand? And if at all, they will give you the rough sheet before you write exam. Things like electronic configuration of atom. Before you start your exam, you can write it on your paper. Yes. Are we together? Things like electronic configuration of atom. Using 1s, 2s.
They don't move on. I don't see that.
N is equals to 1. N is equals to 2.
That's what the rough paper look like.
Okay, this is what it looks like. For jam?
Yes. Somebody that
Oh boy. Let me see. This paper is good enough for you to do your calculation. And see space. If you, it go do you. It go do you. You surprised that some person will not write anything. I'm telling you the truth. But please make use of your rough paper. And if you are being given this before you log in, things like your electronic configuration of atom, draw it. Don't wait until you see the question. Then you want to write 1s1, 2p1. Exam tension will not allow you. Are we together? Exam tension will not allow you. You know your time start reading immediately you log in, right? Or is it will they pursue you from the home? This is an football. Now, are you seeing this? N is equals to 1 to N is equals to 8, right? Now we are trying to get our configuration using SPDF, right? Then we'll start from 1s, 2s, 3s, 4s, is it up to 8s? You are seeing it, right? Now you are having from 1 to 8. Is that okay? Now, you go to the second one to write. Instead of starting from here, you start from here. Is that okay? This should be something you know how to do. Practice it on your own. Memorize it. Memorize it. Then you have what? From here you have 2p, 6p, are you seeing the difference? This S orbital, right? This S orbital, right? We go to P orbital. Which difference do you notice? There's -1 here, there's -1 here. Is that okay? So we get to go to the next orbital. Is what? Is D, right? SPDF. 3D, 4D, 5D, 6D. We stop, right? They say another -1. Then we go to what? F. F start from 4F and what? 5F. And that's all right. Then you're having are we together? Memorize this. Call it. If you want to cram it, cram it. You want to understand it, understand it. But know it. But know it. This is not a problem. Oh. Some people can do it to this extent. But they want to drag that snake. They'll use that snake and spoil everything. When they are going to join now, they will join this one to this. Go like this one to this. Go like this. So see it here now. See it here now. Can we move forward? I'm blocking your view. Toby, are you not drawing it? You don't have challenge with this now. So how is the snake going to go?
So I have challenges with things. So
Okay, you have challenge with the snake.
no, I mean like I have challenges with things too. So.
With things too. Why are you saying that?
I'm a student.
No.
I'm a student.
Even me, I have challenges with things. But I know the one defining wave function, and she corrected me yesterday. So we are bound to make mistakes. We have our weaknesses. You understand? So you want to tell us how the snake will go? Where is it going to go? Am I going to join this to this? Am I going to join this arrow to this place?
It starts from
I'll start from one S, right?
you start from one S
Okay.
to two S, then to two. It's kind of like a zigzag thing.
It's a zigzag, right?
I won't say that passage, but from one S to two S, from two S to two P, then from two P to three S, three
Toby
S
say,
to P.
Toby say zigzag. He has a point. A snake. But if you do not know how this snake is passing, your own will pass wrong. Oh. Now listen. You are wrong. If you connect this to this, right? You connect this to this, connect this to this. That's illegal connection. Maybe I seen it. If you say the snake is passing like this, coming like this, coming like this, coming like this, it's illegal connection. No, I know. I say you have a point. When you say zigzag, are you looking at this thing very carefully?
Yes, sir.
Now, you don't join the arrowhead. Join, and join the back. And you say it's going like this, going like this. Going. That is it now. If you are going now, you should join. And you join. You understand? But this is wrong. Right? This is very wrong. Not just wrong, but very wrong. What you do, just like Toby said, zigzag. Let me borrow your words, sir. He says zigzag. Now, this one join is not a problem. you can leave this to come this way. This first one, right? But you are going from here, it's supposed to come this way. 1s, 2s, right? No, this will also join. It's from here it changes. Sorry. 1s, 2s, 2p, right? 3s, 3p. Is it? Now let's write the configuration for calcium so that we'll know if you are on the way or not. Calcium is 1s1, 1s2, 2s2, 2p6, 3s2, 3p6. So from this now, sorry, 3p6. Now from this now, 1s, 2s, right? Then 2p, remaining 2, 4s2. Is that okay? Now from this now you see, it's coming this way, going like this, coming. Then from 3s, it goes to 3p. From 3p, it goes to what? 4s. 4s. Then from 4s, it goes to what? 3d. Are you seeing it? From 5s, it goes to, from 6s, it goes to, from 7s, it goes to, so it's trickish if you are not careful. And there's no way you can draw this thing in JAM unless before you log in you can use your pencil and play with it on your rough work, and you can write up to calcium or even more than calcium, so that if you are given such question, you see immediately, you just count, you know where it's going to stop. You understand? Because I don't know, but there may be question concerning this in your JAM, right? And they'll ask, what is the configuration of argon? They may not use the short form. If they use the short form, okay, glory to God, you just count the remaining one and you get it from there. But if they did not use the short form and they are using this long form, you will not have that time to start counting, because this is what they are going to use and confuse you. The atomic number will be complete 10 or 11 or 12, but they will confuse you with P, S, 3D, each of them. Are we together?
Yes.
You say, you can't see the board. Are you seeing it now? Are you seeing the way we do it? Now, if you want to bring it out now, we are going to be having what? We are going to be having 1s. He's saying it for me. 2p, 3s,
4s, 3d, 4p,
4,
5s, 4d,
4p.
4d,
Is it 4d or 4p?
5p,
5p,
6s,
6s,
4f,
4f,
then 5d,
5d,
6p,
6p, 7s,
5f,
5f,
6p,
5f, 6d, 7, 7p,
8x,
8s. That's all right. Now, if I'm having this, there's no longer electronic configuration of atom you give me that I will not do. If you say, hello, 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 if you ask me to look for what is the atomic number of copper,
29.
29. If you ask me to look for copper now, I know what to do. First thing you note is that what is the highest number of the election that S can take, P can take, D can take, and F can take. S is what? P is what? D is what? Is it 14 or 18? 14, right? And we are looking for an atom, copper, that is what? 20, is it 26 you said? 29. And copper is 29. I'm having this. It's very, very easy for me to know my copper. Right? It's just you filling it with the maximum number. Then when getting to the end, you are careful. So that whether it's increasing or decreasing. Now we're having copper to be 29. 2 here, 2 here, 6. That's 10 already, right? 2 here, 6. That's 18 already, right? 2 here, 20. 4s is already 20 here. It's 20 here, right? Now we are looking for what? 9. I'll put my 9 here. D, what's the maximum number for D? 10, right? So D can carry this 9. Are we together? So if possible, as at the time I did my WAEC, we were not having good physics teacher. So at that time, just like you, I know some of the secondary school we were not having good physics teacher. Do you know what I did? I'm very good at physics practical. Especially when it comes to light, call me. You understand? So do you know what I did? It's a school that they allow logistic. Somebody was talking about logistics yesterday, that they will pay for logistics. It's a school that they allow logistics. Do you know what I did? I traced all, we are not having enough glass prison and rectangular glass block. What I did was, on a normal day, I went to the lab. I did all my tracing from incident rate of 10, 15, 20, 25, 30, 35, 40 to 50. I did it for reflection. I did it for the triangular block and the rectangular block. And I was having it. On exam day, I enter with it. So when they say draw so of incident rate 10, I just remove it from my plain sheet. That was what I used. So any other angle they ask me to calculate, I already know it.
Conversion time.
Oh, conversion time. Hello.
Hi.
It's conversion time, serious one.
Okay, sir.
So please, if you can, something like this, immediately you are being given your rough book. If you can, do, even if you cannot do till the end, at least 30. So if you cannot, and they ask you, what is the electronic configuration of copper, and if you are faced with it, what will you choose? Is that when you are going to start drawing, and you cannot pause the time on the jam?
Why now?
Hey, person. Let's say,
I will reserve my whole seat.
you people should teach us. Don't go pause time, make them don't go seize your result. So please understand this thing. When you go home, go over it again, practice it again and again. Hello, practice it again and again, because if you are able to get this become easier. If you are able to get this become easier. Is there any question before we move forward? This is something we have done before. We are just refreshing our brain, and I'm hammering on it that you need to memorize it for exam's sake. There are some persons that can actually write this thing without drawing it. They can tell you 1s, 2s. They can tell you how it is, even without drawing it. They are good at that. But me, I cannot. I'll have to draw it before I'll be able to bring it out, to avoid mistake. Can we continue? What's the time, Toby?
How many minutes for? We have 1 hour.
12:08.
12:08.
What I say? We have 2 hours, 1 hour, but
Okay. Can we move forward? Two plus two, 10. Now, like what I was saying the other time, it's just one. Like what I was saying the other time, this is copper now. Copper will not obey Alba principle. And see, this is the configuration, right? From here, we're having 4S and 3D. Right? So instead of 4S and 3D, copper will give you 3D 10, 4S 1. Yes. Check the configuration of copper online. It is what you have. Because they say it will not obey Alba principle. And because of that, D is going to come before the S. Note it. Let's find out. Because they say chromium. If it is, it's what transition metal I say. He has a question that is it generally transition metal that will not obey Alba principle? So I just say let's find out. Please help me check. Can we move forward? Can we move forward? Oh, yeah, right. Police exclusion. Police exclusion. Oh. Paul, okay, write it. Paul exclusion. But you not see Paul in Jambo, it's police you see. Oh. Okay, how do you pronounce it? Eh? Eh? Police. This S, you know, it's showing sign of ownership. Like, what's the name? Victoria's exclusion. Like, okay, there's poly. Okay, not poly. It's poly. Poly's exclusion. To be safe, the pronunciation is poly. Maybe people are doing English now. If you correcting me, anyone I'm wrong. Oh. Let me be here.
I'm not correcting you.
So now, right, it states that a maximum of 2 electrons. It states that a maximum of 2 electrons each. A maximum of 2 electrons each, having opposite spin of 2 electrons each, having opposite spin, having opposite spin. Somebody has already done this. So I was talking about electromagnetic and talking about the spin and the rest. Having opposite spin. This is the spin they're talking about. Something like this. Having opposite spin can fit in an orbital. Can fit in an orbital. Can fit in an orbital. Fit. FIT. Now, it also says that too. No two electrons in the same atom it also states that no two electrons in the same atom have the same value. The same value of quantum number. Quantum. You already know the spelling of quantum. Yes. Quantum number. Who is lost? You? Therefore, if the principal azimuthal, if the principal azimuthal, this is the spelling of azimuthal on the board. If the principal azimuthal and magnetic spin number are the same, yes, are the same for two electrons, they must have opposite spin. So let's practice what we are saying. Now, opposite spin. Okay, let's look at an element, neon. For example, right? Are we together? Neon is having how many electrons? 10, right? The configuration is 1s2, 2s2, 2p6, right? Are we together? Now, it's saying that S is S orbital, this is an S orbital, this is a p orbital, right? P orbital now is divided into 3, right? S orbital is not divided. So if you are to fill in electron in this space, Pauline's exclusion says that the spin must be opposite. If you are having one, this is the first electron, the second one should go down, right? You are having another one, the second one should go down. This 6, if you want to fill it now, you say 1 up, down, up, down, up, down. This is the p orbital, and this 2 is s. Are we together? This is what Pauline's exclusion said. And note, when you are filling this, you are filling it as in up, down, up, down, up, down, because there's somebody that suggested something opposite to what he said. And I'm going to be looking at what he said as well. So that That is Hundro. That's not the work done by police exclusion. So Hundro will say you should fill everything up before you come and start filling down. So if you fill up and it's not enough for down, you should leave it like that. That was what he suggested this one. We need chemists that will be bringing out new theories. People don't want to learn. People don't want to do research and do practical. You see, want to bring a theory out, right? Law of gravitational city. She said what? Up, down, up, down, up, down. Slant form. Whichever way. The most important thing you look at. Hello? The most important thing you look at is the filling in of this orbital. The spin. Up, down, up, down, up, down. That's what we are more concerned about it. Is that okay? You understand? Now, let's look at, somebody should pronounce this. Eh? Eh? Is it? Hans. Somebody will still say hand. Is it not hand? Like in oral English. This is not supposed to be ah. He said what? Toby, is this not supposed to be ah? Yes, like son. He says son. So am I not permitted to call these hands? Eh?
It depends on your opinion.
Hello. Let's continue. That is by the way. Anytime I say oh, you know this is what I'm saying. See the spelling. So don't say it's 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 anything you call it. Just write the correct one. Short form of 100 naira. Somebody just give us another clue now. You have give me 2 horns. You see, 200. Is that okay? Now, who should describe? Yes, you can write. Who should describe the order in which electrons are filled? Who should describe the order in which electrons are filled? First one is Albert principle. Second one is police exclusion. The third one is Hund's rule. These are the 3 major principles they put in consideration when it comes to electronic configuration of atoms. You can come across such question, please. Do you understand? The order in which electrons are filled in the orbitals that belongs to a subshell. In the orbital that belongs to a subshell. Full stop. It states that every orbital in a single subshell is there any word as this? Are you sure? Permit me to use it. It's singly occupied by an electron. By an electron is singly where? Every orbital in a single subshell is singly occupy by an, or you can write by one. That an means one. By an, you understand? By an, that an is talking about one. By an electron before a second electron is filled in the orbital. By an electron before a second electron is filled in the orbital. Let's listen to what, let's look at what Hunshu explained. Now, let's still use neon. Are we together? For neon, we are still having the same thing. We have our S, we have our S, and we have our P. Are we together? This is divided into 3. Also states that, it says that if we're going to fill these orbitals, we singly fill with an electron first, right? Before coming back to continue. Like we're having 10, right? He said that this is how we have to fill it. Up, 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 down, down, and it's finished. It's complete. It's not up to 10. How many is it? Are you sure? 1, 2, 3, 4. Okay. 5, 6, 7, right? Okay, let's use another element instead of neon. Aluminum is what? Aluminum is what? Okay, let's use something smaller. Let's use nitrogen is how many? 7, right? Okay.